Hi children, in that previous video we discussed up to coplanar points and coplanar lines, right? So in this class we are going to discuss about the concept angles. Okay, so angle means what here? The union of two rays with a fixed point or with a common point. Common point or with an initial point is called an angle. So here what is the definition for angle? The union of two rays. Already we discussed about that ray, right? So here the union of two rays with that common point or initial point is called an angle, which means here this is one of the ray, right? Here I am going to take that another ray. So without taking that two rays we cannot form that any angle, right? So that's why here always if you want to form that any angle, always we need to take that two rays. Okay, so the union, which means the region which is formed in between those two rays. Okay, so that union at that common point. Common point means here for example I am going to take this one as O. Okay, so this is I am going to consider as OA. Here this ray is named as OA and this ray is named as OB. So here two rays I take, So once observe that OA and OB, here which one is that common point? Here, yes, the common point is O. Okay, so the union of two rays which is formed at the common point, that one only we will call it as initial point. So that is known as, here which region is formed, that one we will consider it as angle. Okay, so here this one I am going to take it as some theta. What we will call that symbol? That symbol is theta. Okay, so here this is the definition for angle. So afterwards, here we have that two rays in that angles. No, we have some names for that. So here the ray OA. Here OA ray is called fixed ray or initial ray. What is that? OA is called fixed ray or initial ray. Okay, we will call that OA as fixed ray or initial ray that doesn't move. Okay, that's why we are calling that one as fixed ray or initial ray. Next, another ray, that is OB. Here OB we will call this one as OB is terminal ray. Terminal ray or rotational ray. Okay, so here OB is known as a terminal ray or a rotational ray. So in that name only the rotational ray. Rotational ray means the ray which one we are going to use for that rotation. Okay, so here this is a rotational ray or a terminal ray. That ray rotates by using which angle we taken, by using that one it rotates, right? So here that one we will call it as a rotational ray. Okay, after that, what is that symbol? Which one we use to represent that angle? So the symbol which is used to represent that angle. So this is that symbol. Okay, just like that L. So this is the symbol which one we use to represent angle. Okay. So already just now only we discussed that what is the symbol which one we use to represent that angle. So this is that symbol which one we use to represent that angle. Now here this angle how to represent? So this one we can represent it as angle BOA. We can write this angle is angle BOA. In that middle which letter is there? Angle is formed at that middle letter. Okay, just observe that always here we are taking that three letters, no? Here BOA. In that between which letter is there? The angle is formed at that between letter. Okay, so or angle AOB. So here also angle is formed at O. This is another way of writing or another way of representing an angle. Okay, now another way also there. What is that? Directly we can write that angle O. Okay, like that also we can represent, or else here I taken that theta, no. So theta is also angle. So that one also we can represent that. So theta is also that representation of an angle. So these all are that representations. Any one of that, from that anyone we can take and we can represent that angle. Okay, or else here also we can write this one as angle BOA is equals to theta. Why? Because BOA angle formed, what is that angle here? That one I taken as theta, that is formed at O. So we can write this one as angle O is equals to theta. Okay, or else at this place we can take some small letters also, small a, small b, like that also we can represent. So that is also angle A, small a, that is also one of that angle. Okay, now let us discuss about that zero angle. So what about that zero angle? Here already I told you that here to form that any angle we require that how many rays? Yes, 2 rays we require, right? So here also I am going to take that 2 rays. This is O, A. This is that initial ray or a fixed ray. Okay. On this one I am going to take that another ray. Okay. That is OB. Actually here I taken that 2 rays. One is OA, another one is OB. But here what is the meaning of this diagram? Means here 2 rays also coincide on each other. Which means 2 rays also overlapped on each other, right? So here that is the meaning of this diagram. Now here what about that zero angle? Here terminal ray is OB, right? Which is a rotational ray. That rotational ray is exactly coincides with fixed ray. Which means it doesn't move. Okay, without moving, that terminal ray or rotational ray is coincide with that fixed ray or initial ray. That's why here no angle formed. Why? Because here those two lines also overlapped on each other. Then there is no gap between those 2 rays, right? Here 2 rays also there, but here there is no gap or there is no region formed in between those two. I mean here those 2 lines here, those 2 rays, there is no any angle formed here, right? That's why we will call this one as zero angle. Okay. Next one is complete angle. So complete angle means what here? Here also we are going to take that same diagram only, but here a small difference is there. So this is OB and this is A and this is that O. Here also we are going to take that two rays, and here same as that zero angle diagram only. But here what is the difference? Here the terminal ray covers that. Okay, the terminal ray, which one we are going to take? This is OB. This is the same ray only I am going to take. This is O and this is A. So this OB covers that one full rotation. Okay, here OB means that is a terminal ray or a rotational ray, right? So that one covers that one full rotation. After completion of that full rotation, that is coincides with that initial ray or fixed ray. Okay, that is the difference between zero angle and complete angle diagrams. Okay, but looking those two also same only. Okay, but here this is not moving anywhere. Here rotational ray is not moving anywhere, but here this rotational ray completes that one full rotation. After completion of that rotation, one complete rotation, it is coincides with that fixed ray or initial ray. Okay, so here the angle is formed like this after completion of one complete rotation. Okay, so that's why we will call this one as a complete angle. Here angle is formed, but here angle is not formed. Angle is not formed means here zero angle only there. Zero means nothing will be formed, right? So that's why we are consider this one as zero angle. Here this one completes one complete rotation. Okay, that's why we will call this one as a complete angle. But those two diagrams looking as same only. Okay, but this is the difference. So next one, degree. So what about the degree? Just now only we told about that complete angle, right? So complete angle means what I said here. This rotational ray completes that one complete rotation. So it forms that one of that circle only now here. It forms that one of that complete circle. So here a complete angle which is exactly divided into 360 equal parts. How many equal parts? 360 equal parts, which means one complete angle is divided into one complete angle means it completes that one complete rotation. No? So here this is divided into 360 equal parts. Okay, like this way we have that so many parts, but here each part, this part is equal to that next part, this part is equal to that next part. So here like this, totally how many parts are there in that complete angle? So here totally 360 complete equal parts are there. Okay, how many equal parts? 360 equal parts. Each equal part we will call it as degree. Okay, one complete angle is divided into 360 equal parts. And each part is called as, we will call that each equal part as degree. Okay. So here what is the symbol which one we use to represent that degree? So here small 0. This one represents that degree. Okay. For example 9 degrees. So we will write this one as 9. At the top of that 9 we have to represent that degree symbol like that. Okay. Or 10 degrees. 100 degrees. Okay, like this way we can represent that degree symbol. Okay, so what about that degree? Once again, one complete angle is divided into 360 equal parts. 360 equal parts. Each equal part we will call it as degree. Okay, so after this one we need to discuss about that types of angles. So here in types of angles, the first type of angle is zero angle. So already we discussed about this one, right? But here this one, how much measures we didn't discuss. So first one is zero angle. The diagram is same. What is that? Terminal ray is coincides with fixed ray or initial ray. Okay. So that is the diagram for zero angle. So here zero angle, here theta measures that 0 degrees. Here I am going to take that, consider as theta as that angle. So theta is equals to 0 degrees. No angle will be formed here. That's why that one we will call it as zero angle. Next one is complete angle. So complete angle, it measures. Already previous we discussed about the degree, right? In the degree I told you that one complete angle is divided into 360 equal parts. That's why here complete angle measures 360 degrees. Okay, so theta is equals to 360 degrees. Okay, so what is the diagram? So again the same diagram, this is for OA and OB. OB coincides with OA. And here angle will be formed. Why? Because it completes that one complete rotation. Okay, that's why here theta is equals to 360 degrees. So first one is zero angle and the next one is complete angle. After that, third one is acute angle. So this is the representation for acute angle. OA and this is OB. So here some of that angle is there. So this is the symbol for acute angle. So acute angle measures here the angle which is greater than 0. Already we discussed about that zero angle, right? So the angle which is greater than 0 degrees. Greater than 0 degrees means we can take from 1 onwards, right? 1 degree, 2 degree, 3 degrees like that. So greater than 0 degrees and less than 90 degrees. So 0 degrees is less than theta is less than 90 degrees. So what is the meaning of this statement? Means here the angle which is lies between 0 degrees and 90 degrees. Those all angles we will call it as acute angle. Okay, which means 1 degrees to 89 degrees. Any value, any angle we will consider it as acute angle. Okay, so what is the definition for acute angle here? The angle which is greater than 0 degrees. Here I am going to consider this one as OA is that fixed ray, right? Okay, so the angle which is greater than 0 degrees. So this is 0 and this is, we can take something here 30 degrees, 60 degrees and 45 degrees. Any angle we can take in between that, those two rays. Here what is that 90 degrees? This is 90 degrees angle. So the angle which is lies in between these two rays. Okay, this is OB. Okay, so the angle which is lies in between OA and OB, and here OB I am going to consider it as 90 degrees. Okay, if you by using that protractor we can measure that angles, no? So once observe that protractor like this only, you will get that 90 degrees angle. Okay, when you observe that a protractor like this only there, no? This is the shape of that protractor. So exactly here we can see that here we can observe that 90 degrees and here we can observe that 0 degrees. So what I am saying is the angle which is lies in between 0 degrees and 90 degrees, we will call these all angles are acute angles. Okay, here 1, 2, 3 like that we have that so many angles up to 89. So 1 to 89 all angles we can consider it as acute angles. Okay, that's why theta is lies between 0 and 90 degrees. Is it clear? So next one is, next fourth one, obtuse angle. So here obtuse angle means the angle which is greater than 90 degrees and less than 180 degrees. But here before going to that obtuse angle, we need to discuss about that right angle. So why? Because right angle measures here theta is equals to 90 degrees. Why? Because already I told you that, right? So this is the protractor. Here we can observe that 90 degrees and this is 0 degrees, right? So this is 90 degrees. This part shows that 90 degrees. The same exact part left side also there, no? So this is also measures that 90 degrees angle. Okay. So here 90 plus 90, this is 180 degrees. So in a protractor, we can observe that totally 180 degrees angle we can observe here. Okay. So here this is 90 and this is 90. So we will call this 90 degrees as right angle. Okay, so here right angle measures theta is equals to 90 degrees. Okay, now come to that obtuse angle. This is also one of the type. Okay, so come to that obtuse angle. Here the angle which is greater than 90 degrees and less than 180 degrees. So greater than 90 degrees means here the angle starts from 91 degrees to 179 degrees. So 91 to 179 degrees, any angle we can consider it as obtuse angle. Okay, so here the angle which is lies in between 90 degrees and 180 degrees. Okay, so here theta is lies between 90 degrees and 180 degrees. So 129 degrees. Okay, for example, 129 degrees, that is which type of angle? Yes, that is obtuse angle. Why? Because 129 is greater than 90 and that is less than 180 degrees, no. So we can consider that one as obtuse angle. Okay. So after that obtuse angle, this is fourth one, 5, and sixth one, next one is straight angle. Okay, so what about that straight angle? Okay, already we know that 0 degrees means 0 angle and this is a right angle, and what we will call this 180 degrees. Okay, that 180 degrees we will call it as a straight angle. So here theta measures 180 degrees. In a straight angle, theta measures 180 degrees. Why? Because just observe that here this is a straight line. Okay, here I am going to consider this one as a straight line. This is O and this is A and this is B. So OB is that a terminal ray or rotational ray right here. So this one completes that one half of the complete angle. Okay, this ray completes that half of that complete angle. So complete angle is 360 degrees. Half of the complete angle means into 1 by 2. So which measures that 180 degrees. So this one completes that half of that complete angle. After completion of that half of that complete angle, those two rays forms here a straight line. Okay, those two rays forms here. Which rays? One of the ray is terminal ray and the ray is initial ray. So initial ray and terminal ray, those two forms here a straight line. Those two forms here a straight line. So on a straight line at that common point, Okay, at that common point here, what is the total angle? This is 90 degrees and this is 90 degrees. No, that's why here straight angle we will call it as 180 degrees. Straight angle measures 180 degrees. Is it clear? And one of that important point, what is that? At that straight angle, initial ray and terminal ray, those two becomes opposite rays. Okay, those two rays becomes opposite rays. Just observe that this is a straight line. Okay, those two rays forms here a straight line. One of that one shows right hand side, another one shows exactly left hand side, and those two forms a straight line, right? Okay, and those two also shows that opposite rays. Those two also become as opposite rays at that 180 degrees. Okay, so here theta measures 180 degrees. So straight angle measures 180 degrees. Clear? So next one is reflex angle. Next one is reflex angle. Reflex angle means what? Here already we know that up to 180 degrees we learned that. After that, greater than 180 and less than 360. Once you observe that, if you rotate that protractor like this, it forms that one complete circle, right? One complete rotation it forms means one complete angle. So here when you observe that protractor, here this one I taken as protractor, right? So 90 degrees, 0 degrees and this is 180 degrees. After completion of that, greater than 180 and it forms again the ray coincides with that fixed ray. Yes or no? Here I am taking this one as terminal ray or a rotational ray. This rotational ray, after completion of this complete rotation, it is coincides with a fixed ray. So again we will call this one as 0 degrees, also we can call it as 360 degrees, no? So that's why here the angle which is lies between 180 degrees and 360 degrees, here we have to observe. Okay, so the angle which is greater than 180 degrees and less than 360 degrees is known as reflex angle. So here the theta lies between 180 degrees and 360 degrees. Is it clear? So the theta lies between 180 degrees and 360 degrees. So here what we will call 181 degrees to 359 degrees. Any angle we will call it as reflex angle. Okay, in between 180 and 360, here we will get it as 270 degrees also. So 270 degrees is which type of angle? Yes, 270 degrees is reflex angle. Okay, so after completion of this rotation, again this is coincides with that initial ray, right? So here that's why again we can form that complete angle. Okay, so these all are the types of angles. Once again say the types of angles and it measures. Okay. Okay, once again see that measures. Here the first one is 0 angle. So here theta exactly equals to 0 degrees. So 0 angle measures 0 degrees. Next complete angle, here angle measures 360 degrees. So here theta is equals to 360 degrees. Next acute angle, the angle which is lies between 0 degrees and 90 degrees. So we can take this one as 1 degrees to 89 degrees. Any degree we can consider it as acute angle. Next, right angle means here theta measures exactly 90 degrees. Okay, that is right angle. Next, obtuse angle means angle which is lies between 90 degrees and 180 degrees. We will call that angles as obtuse angle. So which angles we can consider here? That is 91 degrees to 179 degrees. Any angle we can consider it as obtuse angle. Okay. After that, straight angle. So straight angle means theta exactly measures 180 degrees. Okay. So next reflex angle means Here the angle which is lies between 180 degrees and 360 degrees. So here we can consider that 181 degrees to 359 degrees, any angle we can consider it as a reflex angle. So these all are the types of angles and it measures. Okay.